So in this section, we're going to look at our linear inequalities that we graphed with single linear inequalities, and now we're going to apply systems to it. So we're going to look at two or more linear inequalities and what the graphs look like. So when you're graphing a system of linear inequalities, which is our objective to be able to graph those, the first step, so we'll do our steps here, the first step is draw the boundary line. The boundary is going to be the line, or in other cases you could use other functions, but you have to remember whether you're going to make it dotted or solid. Just like when we did, for instance, x is less than 4, we graphed that, if you recall, as a 4. We had an open dot on that. Okay, so we put an open dot on 4, and we shaded in that direction. Well, just like that, our boundary lines could be open. And how we draw that is if we have a less than or a greater than, we make the line dotted. If we have a less than or equal to or greater than or equal to, we make it solid. Okay, so first thing, draw the boundaries, okay? Second, after you do that, you shade each of the two or more, and you're going to shade them, but don't do it to the final extent because we're gonna have to do the overlap. So shade each, but then you look for the overlap of the shading for the final answer. This is like when we did the intersection of our graphs. When we were doing our inequalities before, we did the and problems, we did intersections. It's the same thing here. We look for the overlap. Okay, so let's take a look at what this means as an example. Okay, persevere through these problems, persist through them, because you're gonna have to do more than a step or two, so you're gonna have to work your way all the way through it. And we have two inequalities here to graph. Let's persevere our way through it. So first thing is, this first one I'm gonna draw the boundary line. It's gonna be a solid line because it's or equal to. So I'm gonna start with that -3. My slope is 2, so I'm gonna go up 2 over 1, up 2 over 1. And I'm gonna draw a solid line through those. Now we've got to test to see, do we shade above it or below it? So if we put in 0, 0, which is a point above it, is 0 greater than or equal to 0 minus 3? The answer is yes. So all I'm going to do is I'm going to mark that I want to go on this side of it. It's a good way to mark it and wait for our final overlap to graph. Now let's graph the next one. Let's go ahead and graph y is less than the opposite of x plus 2, so start at 2. Opposite of x is down 1 over 1, down 1 over 1, down 1 over 1. I'm going to make this a dotted line because it's not or equal to. So draw in your dotted line. And now when I test 0, 0, which is below it, is 0 less than 0 plus 2? It is, so that's true. I'm going to shade on this side. So when I look above this, below this, where the two of those overlap is where these two are pointing together. So my shading looks like this region right here. Okay, so I shade this right here. And that's my final graph. Solid line, dotted line, and between these two where the shadings overlap. Let's try this one. This one has 3 of them. Let's take a look at doing 3 of them. So we'll start with, I'll do red for the first one here. Okay, so on this one, what I get is I start at 1. I have a slope of 1, so I go up 1 over 1, up 1 over 1, and keep going, down 1 over 1. Okay, and that's going to be a dotted line because it's not or equal to. So I'm going to draw my dotted line. sure it's clear whether it's dotted or solid on this. Okay, now, this, if I put in 0, 0, which is below the line, is 0 greater than 0 plus 1? And the answer is 0 is not greater than 0 plus 1, so I'm going to shade on the other side and go above this one. Now let's do the next one. We'll do this one in blue. This is also going to be dotted. So x is greater than 3. X equals 3 is a vertical line just at 3. So I'm going to do a dotted line there. Okay, and if you put in 0 for x is 0 greater than 3, the answer is no. So I'm going to shade on this side of this one. So far I've got this region right in here because that's above this one and above that one. And lastly, let's do the y is less than 6. So my graph will do that in purple. This will be dotted. So I'm going to start at 6 up here. I'm going to make a dotted line. And if I put in 0, is 0 less than 6? It works. So that's shading below it. So where do these three, above red, below purple, and to the right of blue, the overlap is just this little tiny triangle here in between. Okay, so again, it took several steps to get there, but we got the region that is the overlap of all three of those is the system. All right, so let's take a look at this one now. So for this one, if I graph the first one here, I start at 1, and I go down 3, 1, 2, 3, and over 1, 2, 3, 4. Okay, and I'm going to make it a solid line, as it's or equal to. Helpful to sometimes even write the word, but make sure it's clear on the graph. And now is 0 greater than 0 plus 1? And the answer is it is not, so I'm going to shade on this side of this one. Now we'll do in blue the other one, so start at -2. And then my slope is -3/4 again, which makes it parallel, 1, 2, 3, over 1, 2, 3, 4. Okay, and draw a line. This one also is solid. Now, if you look at this one, 0 is less than 0 minus 2. I'm sorry, 0 is not less than 0 minus 2. So I'm going to shade on this side of this one because 0 doesn't work for it, 0, 0. Now, there is no overlap for above this red one and below this parallel line where we're going below it. So this is no solution because there is no overlap to those inequalities. All right, let's do this last one here. I'm going to shade this. Okay, I'm going to start with, let's do this one in blue. Okay, I'm going to go ahead and just put these as, put this in the slope-intercept form. So the opposite of y is greater than or equal to, subtract 2x minus 1. And now when I multiply by -1 here, I get swap the inequality by flipping it because we multiply by a negative. So we get 2x plus 1. I'm going to start this one at 1. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over a -1, down 2 over a -1, down 2 over a -1. And this one will be solid. So I'm going to draw a solid line then through these. Okay, 0, 0 is below this line. So if I put in is 0 minus 0 greater than or equal to a -1, and it is, so I'm going to shade on this side of it. So here, shade on this side, shade on this side of it. Okay, let's do this one. We'll do it in purple. Okay, I'm going to do this one with intercepts. If I put in 0 for x, I get out 4 for y. If I put in 0 for y, I get out 4 for x. It's going to be a solid line, so I'll put solid on this side, so I know it's a solid line. Draw a solid line in there. And if I put in 0, 0, is 0 plus 0 less than or equal to 4? It is. So I'm going to go on this side of this one. So far I've got this side and this side, which would be down here, if I was just stopping at those two. And now let's do the last one. We'll do this one in red. Okay, so this one I'll go ahead and get in slope-intercept form. So 4y greater than or equal to opposite of x plus 4. Divide every term by 4. Does not flip the inequality because it's not negative. So y is greater than or equal to negative 1/4 x when you divide by 4. And divide this by 4, you get plus 1. So I'm going to start at 1, just like this other one. And then we go down 1 over 1, 2, 3, 4. So it goes through there. Down 1 over 1, 2, 3, 4. And then I have a solid line for this one as well. Okay, let's move that back. There we go. So a solid line. Okay, and so I draw the line here. Now test 0, 0 is below it. Is 0 plus 0 greater than or equal to 4? The answer is no, so I'm going to shade above this one. So my region is this little area down here where these all cross, okay? So this is my region of where these intersect. What I want to know when it says find the points of intersection, these are the points where it intersects. It intersects here at 0, 1. That's that point right there. This one is at 4, 0. And this one right here is going to be 1, looks like 3 for my intersection points. So to do a system of inequalities is like a system of equations. You're finding out where they intersect. In this case, it's the shading. So you do each individual linear inequality, find out where those shadings overlap, graph that region, and now you have the solution to the system of linear inequalities.